Okay, thank you very much for coming to this session. And yeah, we're going to talk about Java and Kubernetes. And yeah, this is, we are in a cinema, right? And I think it's a good idea, to mix these films that probably all of you have seen this summer. So who of you have seen Oppenheimer? And Barbie? Oh, come on, we're all Barbie.
I know there's more of you that have seen Barbie. You're just a little shy.
We're all Barbie. Okay, so my name is Alex Soto. My Twitter is AlexSotoB. My email is soto@redhat.com. Feel free to reach me in any of these channels. And also, I'm the co-author of all these books.
And I'm Kevin Dubois. I'm on the same team as Alex at Red Hat. And I'm also part of the Belgian Jug. Are there any Belgian Jug members here? All right, we need more, right? Who is here from Belgium? You need to join. Come on. All right, so let's get going, right? So the title of our session is Kubernetes from zero to production grade with Java. And so basically, we're going to build a kube native Java application, and we'll play this little role-playing game. You'll see, but so we're going to be creating a kube native Java application, right? So what is kube native? What's the difference between that and let's say a traditional Java application? Well, and I'm sure you've seen similar sessions where they explain, like traditional Java wasn't really built for containers and Kubernetes. It was more built, for big systems where you get throughput at the expense of footprint, and the startup speed wasn't so important because you have long-running processes and dynamic behaviors to run your application. And the idea was, these application servers, keep them running as long as possible. But that doesn't really work for Kubernetes and containers, right? With containers, the idea is that you solve throughput by scaling horizontally, by creating more instances and more pods when you need it, and then you scale back down so you can use your resources more efficiently. And so you need a kind of a different approach to running your applications. In addition, containers are supposed to be more or less immutable. So like if every time you start up a container, you do all that kind of warm-up stuff that the JVM does every time again and again, and all that startup dynamic behavior in each container, that doesn't really make sense. You lose a startup time that you really need, because when you're scaling in Kubernetes, the idea is that you kind of scale based on what you need. And so if you get a lot of requests in and you can't handle the load, then, well, that's not so good, right? So again, for those who have seen the Barbie movie here, they kind of hit this obstacle or something and their car spins out of control. So in Kubernetes, kind of the same problem, right? If our application doesn't start up fast enough, we can't scale fast enough, and then our requests are going nowhere, and our managers are not going to be so happy, right? So we need a solution in Java that can start up fast and that can also use less resources, because the footprint is also really important in Kubernetes. And so there's, of course, the Java community is super awesome. There's several approaches to solving this kind of problem, to make Java faster in terms of startup time, to use less resources, right? So we have we have GraalVM with a native image, we have Project Crack, and we have some frameworks that do a really great job at kind of making the startup faster and making the applications faster too, by moving more to the build time instead of during the startup time. So one of those stacks, and of course we're a little biased, but I really love Quarkus, so that's going to be the stack that we're going to use today. That doesn't mean that you can't achieve kind of the same things that we're going to cover today with other stacks, but we're going to focus on Quarkus. And I'm sure a lot of you have probably seen this slide before, where you can see kind of the difference between a traditional Java application in terms of memory footprint, in terms of startup time, and then Quarkus, and you can see kind of the advantage of using a stack like that, where you get a lot faster startup time. But so when we're developing our application for Kubernetes, it's also, us as developers, are we now supposed to be Kubernetes experts? Well, maybe not, right? Because that's a lot to take in. So that's another cool thing I think about Quarkus is because it has this kind of developer joy, a developer experience initiative too, where we try to make everything a lot more fun and easy for developers. So let's take a look at that, right? Let's just quickly create an application with some stuff, and then we're gonna make it Kubernetes ready and maybe production ready. We'll see.
Yeah, we'll see in a moment. Yeah, I mean that we're going to, for starting an application from scratch, Quarkus application. In fact, and that probably most of you have seen maybe a Quarkus demo with a database. In this case, we're not going to use a database. We're going to use Kafka, right? But just to show you something different.
Yeah, because our end goal is to create a really cool game, and so hopefully, if everything goes well, you'll actually get to play along. But let's start with this, right? So Quarkus create app. So you have this Quarkus CLI. That's one way to create a Quarkus application. You can also go to quarkus.io or whatever, but I'm gonna use the CLI because doesn't that look way cooler? All right,
I usually use the page, which is code.quarkus.io, but yeah.
But
Kevin loves CLIs.
Yeah, exactly. I'm a Linux guy.
Yeah. I like click.
So Quarkus create app, and then whatever the name is, and so I'm creating my Quarkus application, and the new version of Quarkus was pushed this morning. So fortunately, my good friend Daniel here told me, like, hey, you should probably cache the new dependencies, otherwise we would have been seeing some downloading of dependencies. Anyway, so let's start our application. I know you're all VS or IntelliJ people here, so I'm gonna open it in VS Code. All right, so when you do Quarkus create app and you don't supply any dependencies or extensions or anything, it's just gonna create a small application with an endpoint, which is in this case the greeting resource.java, and so it has like hello from REST Easy Reactive because it added a REST Easy Reactive dependency, and so I could run this and then you could see that it's works, but we're gonna create something more interesting with Kafka in this case. But I'm gonna start my dev mode on local machine. So again, for those who know Quarkus, and I hope that's all of you, but maybe not. So you can start this dev mode, and so that basically runs your application on your local machine and gives you live reloading, hot reloading, and all that stuff. So that's pretty handy to do. So let's create a new file, and it's gonna be my consumer of Kafka, right? So before I do that, of course, I want to add an extension to dependency on Kafka, so let's do that real quick. So I have the Quarkus plugin here for VS Code. It also exists for IntelliJ, don't worry. And so I have, of course, I want to have a dependency on Kafka. So there's a few of them. The one that I'm going to use here is small RI reactive messaging. That's not really the point of this talk, but it's a pretty handy extension. So what you're going to see is by just adding this dependency, this live reload is going to reload, and it's going to start up a Kafka test container on my local machine. So just by me adding this dependency, I have here in my in my Podman desktop, you can see here there's a new container running with test containers based on Red Panda. So I have already a Kafka on my local machine by not doing anything. So that's pretty handy for me because otherwise I wouldn't know where to start. All right, so let's create this consumer real quick. So we're gonna do application scoped, and then come on, and then let's do a consumer. So
you can see that the first annotation is from CDI spec or Jakarta CDI spec. Then now we're going to start using the small RI messaging annotations. So, and you've seen that the Kafka cluster have just boot up super fast and automatically. So we've not done anything, just Quarkus dep. And when we added the dependency, automatically Quarkus start using the test containers project, the Kafka cluster.
Right. So let's say that I'm getting an incoming power event. So our little game is going to run with cars, and they're going to report their power events to power these cars, right? So this is like the start of our application. So I got an incoming power event. So this is based on microprofile, if you're familiar with it. So just a basic incoming event, and then we'll log it. So I can just do log info incoming
And you see
power
that,
event.
yeah, that Kevin is coding, and we are never doing something like Maven clean package, Java -jar, nothing. We just done Quarkus dep, that's all. Never Maven clean package, stop the process, Java -jar, nothing. We just code, and while we code, the application is automatically updated.
Yeah. So let's see if it actually works. So another cool thing. Oops, and I'll go to a different browser here. So in Firefox, and then I'm gonna open what you have in Quarkus is this dev mode. So I can go to localhost 8080/q/dev, and then this is when you run Quarkus in dev mode. And you can see that there's an Apache Kafka client card that it added because it noticed that, hey, you're using a Kafka dependency. And what's cool with this is that you can see the topics that have been created, and it already created a power topic, even though I didn't do any kind of configuration or anything. No. So that's pretty handy. Just because I created that class with the power incoming event. So, and then you can see, right now we don't have any events, but let's see if we can create one. The key is going to just be some random key test, and then we'll do the value, whatever, something, and then create. And then let's go see if our event is there, and sure enough, we got incoming power event 5000. So, just in a couple of minutes, we were up and running with Kafka on our local machine and already consuming events. So that's pretty cool, right?
And as you've seen, no clean package, no Java -jar, and for free you get this deb UI. Okay, you've seen that we've created the project from scratch, so there is no secret. We have not done nothing before the session. We just created the project. And you see all these great things about Quarkus.
Yeah. So I have this cool application. I'm ready to go and deploy it to Kubernetes. It's already pretty much finished.
Yeah.
So I added a Kubernetes extension to my Quarkus application here. And so just by doing that, we're going to see that because I'm still running in that live mode, so every time you make a change, it reloads what you need, and it created in my target folder a Kubernetes.yaml. So I don't know how familiar you are with Kubernetes, but so by kind of default in Kubernetes, you need a deployment and you need a service. And I don't know about you, but I can't write all that YAML off the top of my head. So by just adding the Quarkus Kubernetes extension, it actually generates this for you. So it creates the deployment and the service, and then based on some container image that I haven't created yet. So I'm going to go to my application properties now, and I'm going to add some values so that I can create my container image, which I already could, but I want to create it with a specific name. So I want to push it to a specific image registry. I want to push it to quay.io. And then I have to specify a group. So Quarkus container image group, Kevin Dubois, because that's my Quay registry. And let's add
you can set the tag or not. Right. If you don't set the tag, then it will take the version number of from pom.xml. If you don't put the name, then it will take from the name or the artifact ID. So there are these values are optional. You can just rely on the defaults or just overwrite.
Right. So I'm going to stop my live mode right now because I'm going to actually kind of productize my application. So Quarkus image build if you have the CLI. Or you can do Maven Quarkus build. So just by doing Quarkus image build, it's going to create a container image. But let's make it a little more interesting and actually do Quarkus push also build. And by just running this command is going to package my application, put it in a container, and push it to my registry. So hopefully I'm still logged into my registry, but let's see what happens. So Quarkus push.
The credentials comes from, now we get some kind of an authentication error. Basically, what we should do is do a Docker login. So we do Docker login, and then the Quarkus CLI, actually it's the Quarkus container extension will automatically read the credential from there.
Yep. So I probably just got logged out of quay.io. Looks like it. Yep. So I'd have to do podman login. Kevin Dubois, and then I have to go find my password somewhere. Let's imagine that I pushed it. Yeah, right? Okay. But it did create the container image, right? So if I go to my images here in Podman Desktop, you can see Kevin Dubois, my awesome app. So it did actually create my container image. Actually, if I had added -- native to the command, it would actually have built a native build of my container image and push that into an even smaller container image. So, but in this case, it's just on the JVM, because it's a little faster. Okay, so let's say I push this application because I don't want to go get my password, and so now I can just do podman deploy because I'm already logged into my Kubernetes cluster. Podman, or not Podman deploy. What am I saying? Quarkus deploy. Quarkus is going to use the Kubernetes YAML that it generated to actually push the application to a Kubernetes cluster. So in my case, I already have one where I'm logged into, and it happens to be a Red Hat OpenShift.
You can see now.
And you can see the application just appeared, and it should, pull the image, but of course, because I didn't push it, that wouldn't work. So.
Yeah, and this works with Kubernetes, with OpenShift, it's not specific for OpenShift. If you've got Minikube, it works as well. Kind, and in any Kubernetes cluster, it just works because under the hood, this Quarkus deploy command, what it's really doing is just doing kubectl apply of the YAML file.
Okay, so let's pretend that I pushed an image with the name Quarked. I'm pretty sure that one actually exists, so I'm going to cheat a little bit just to show that we got a running application. So let's go back to Firefox, and we can see the new application is up and running, and now it's actually running, right? So we can view the logs and see that, and this one was created with native image, so you can see 28 milliseconds for this Quarkus container, so that's pretty fast. Anyway, so I think Alex, that I'm ready for production.
Yeah, let's see. Yeah. Well, at the end, this was just a hello world, right? So putting a production, a hello world application, it's easy. Putting a real world application into Kubernetes might be harder, and you might need to know some things, right? Because at the end, you've seen that if you're using Kafka, probably in production, you will need to set some kind of passwords, secrets, certificates, these kind of things, right? And to put this in Kubernetes, you need to use, or you might use Kubernetes secrets. Let me tell you one thing, is that even though they are named Kubernetes secrets, they are really not secrets. I know that name might be confusing. I encourage you to use some kind of secret management like HashiCorp Vault. But if you cannot use it, if you need to use Kubernetes secrets, please always inject the secret as a file and not as an environment variable, because usually the environment variables are printed in some log files. So if you lose these log files, you're going to lose also your secrets.
Okay, cool.
So let's see how we can, consume secrets from our Quarkus application.
Okay, that's cool. So I'm going to just add another dependency here, another extension. There's a Kubernetes config extension. And so by adding that, and let's start our dev mode here again. So Quarkus, Quarkus dev. And so I added a Kubernetes config extension, which allows me to interact with secrets and config maps and those kinds of constructs in Kubernetes. And so I can just, in my application properties, tell Quarkus to look for specific secrets. So you can do Kubernetes secrets. Let's see. I'm just going to type it out. Quarkus, Kubernetes, config, secrets. And then I can supply the name for it. So let's see. Secrets enabled. We have to enable it first. And then You said we need to use volumes?
Yeah, we can use
Okay.
volumes,
All right.
or we can consume directly using the Kubernetes API. So with this extension, you can set use a secret from a volume, or just use the Kubernetes API to do a request to the Kubernetes and get the secret directly. So you are never mounting the secret as a file into your pod or as an environment variable. So you have these two options.
Yeah. Yeah, so we have, so like I said, the Quarkus Kubernetes config, so you add secrets enabled, and then supply some secrets name, and then if everything goes well, if the live reload works, I saw there was an error, so let's see what it is. Let's just try it again. And so by adding the application properties, we're going to see that secrets are going to be added to the manifests that Quarkus created, right? So it's going to add like a service account and add permissions to read the secrets and everything. So it looks like there's an error, which is all. Yeah, we're doing live demo, so of course inevitably we're going to run into some error. Yeah. So let's go and look at my little backup project, because of course we have a backup project.
I didn't remember to burn some Windows XP.
Yeah, exactly. This is your
We need to sacrifice to the demo gods.
Yep.
We miss it. So
yeah. So let's go
this is what happened.
Okay. So in this case, look at the Kubernetes YAML. There we go. And so you can see here what would have been generated, which so a service account and a role binding and all that stuff that that I'm not an expert in. But so I get all that information for free, so that my platform engineer or DevOps person or whatever can use that to interact directly with secrets, and I can consume them in my application. So secrets.
Yeah.
Good.
So we've got secrets.
Yeah.
Then I don't know if you know exactly how Kubernetes works when it starts a container. When Kubernetes starts a container, the first thing that it does is just running the command that you defined in the container, and at that point, the container is running, and Kubernetes will start sending traffic to this container. So you can see that just at that point, when it executes the java-jar thing, at that point, Kubernetes will start sending traffic. The problem is that your application is not ready. Your application is ready at this point, after 2.6 seconds. So you need to wait 2.6 seconds until the application is really ready, which means that you've got this downtime of 2.6 seconds, because Kubernetes will send you traffic even though your application is not ready. How you can fix this? Okay, by using a readiness proof. A readiness proof, basically, it's like a polling system that is just querying your container until it returns this endpoint. In this case, the endpoint is /health, as you can see here. When this /health endpoint returns a 200, it means that the application is ready, and then after that point, Kubernetes will start sending traffic, not before. Okay? So how we can put this in our application?
It couldn't be easier, really. Let's add another extension. So add extension, and so in the microprofile spec, there's actually Kubernetes health. So we can just add small-ri health. So small-ri is an implementation of microprofile that you can use with, for example, Quarkus. And by just adding that extension, what we're going to get is that when it generates our YAMLs here, we can see that we get this liveness probe already added to our manifest. We have a readiness probe and we have a startup probe. So really, that's it. I just added the health endpoint or the health extension, and now we have health endpoints. And we can customize them. But the cool thing is that not only did it add it to the manifest, if I now go to my application and go to /q/health, I will actually see how that all is working. But since my other application is having some issues, I suspect it's container issues. So
yeah, because it says something about Kafka.
Yeah, so we can try it, but I don't have much.
Maybe it works. Maybe this endpoint works.
We'll see.
Maybe not Kafka, but the endpoint works. So basically, with this extension, it registers automatically the endpoints into the application, and also, of course, generates this YAML files, okay? So, okay, now we are ready. So we know when the application is ready to start accepting traffic. But there is another thing, is that you know that in the past, with Java, we got it big machines, right? 16 gigabytes of memory, 8 CPUs,
That's it?
all the machine for you, right? More, 32, okay, 32 gigabytes, okay, that's fine. All the machine was for your application. Nowadays, this is not the case. Sorry. Nowadays, we've got a Kubernetes node that has an amount of CPU, an amount of memory that needs to be shared across all the containers that are running there. So, what's happening if you do not put any limit? If you do not put any limit, the container will start consuming as much as CPU and as much as memory as it requires. So, no limit until you get it out of memory. And that might be fine. The problem is that if you're running more containers in the same node, these other containers will be affected by the memory used by another container. And this is something that probably you really don't want. So to fix this problem, we've got the resources part, where you put here, you can see the requests and the limits. So you put limits on the CPU, requests on the CPU. What you want to see here is that the request is the amount of CPU that you want to use at boot up time. Okay, so this is the CPU that you're going to use, that you require. So if this CPU is not available in your Kubernetes cluster, the application will not start. And also guarantees that this amount of CPU will be available all the time. And then we've got the limit. The limit is how much CPU you could use at most, right? So it's not just the required, just you can use one CPU, but maybe you need two CPUs. So you can also use two CPUs. But you see that it's in this black color, which means that it's not guaranteed. So in the limits, you have no guarantee that it's going to work. With the CPU, it's not a really big issue, because the only thing that happens is that your application will go or will run slower. So yeah, okay, it will go slower, but it's not going to crash. The problem is with memory. When you put the request in memory, this is the amount of memory that you need to boot up the application, and this memory is guaranteed. The problem is that the memory that you've got in the limits is not guaranteed. So you can use it if it's available, which means that maybe you put a request of 1 gigabyte, a limit of 2 gigabytes, and when you start using 1.5 gigabytes, your application just explodes because it gets out of memory, because the limit is not guaranteed. So if you...
So Alex, I put my limit to 2 megs of memory, and I keep getting this OOM killed.
Yeah,
and no
exactly.
possible start. Oh, so that's why.
That's the point. Yeah, exactly. So if you get this, you will get some status of OOM killed. So no worries. I mean that Kubernetes will kill the pod and will restart again the pod. So it's not...
And kill it again.
Yeah, exactly. So, okay. So if you want to get a guarantee of the amount of memory reserved for this pod, you need to put the limit and the request at the same value. So if they're the same value, then there's guaranteed that you're going to have the big amount of memory for you. And of course, you can still get out of memory, but you will get a get of memory, let's say, easy to understand why happens. The other way, you never know if you get it out of memory because you reach the limit, or because in the middle of the limit, you get it out of memory because another container used that memory, right? So you might say, okay, and what could be a good initial values? And here I want to report this blog post from our colleague in Microsoft. Thank you, Bruno Borges, for doing it. And it's really nice way, right? It's like 2 CPUs, 4 gigabytes, 75% of heap size, and parallel GC. Usually this works pretty well, or it's a really good starting point. And of course, you can set it in this way. So you put here the resources, and then as an environment variable, you can use this special environment variable, which is JDK Java options, and you said you want to use parallel GC, and you see here the max run percentage, 75%. It means that it's going to use the 75% of the memory that you set in the request. So you can see that it's not an absolute value, it's a relative value, depending on what you have defined in the resources section. So Kevin, let's see how we can add this into our application.
All right, let's do it. So let's go back to our other application that's also not working because, well, at least not with the Kafka extension. I guess I could remove the Kafka extension. And
remove
then
the
it might
Kafka
work.
extension.
So,
Yeah, we're going to remove it.
Let's,
if you want to run
let's
it.
do remove extension. Does that work?
Or
No.
you can just go to
I
the
can just do the
pom.xml.
CLI.
You see that an extension is just a jar file,
Yeah,
okay?
exactly.
So you just open the
Okay.
pom.xml,
Let's
remove,
do that.
and
Pom.xml.
delete the consumer class to not get
Yeah.
compilation errors. And
So
we
let's
are good.
remove that one.
Yeah, you see that it's just a jar file. But with the extension, with the Visual Studio Code, extension of IntelliJ, Quarkus extension, you just add them easy. Okay,
Wait.
now it's going to start.
All right, so let's start it back up again. Let's see if everything will work.
Yeah, we can
And
test
in
the
the
health check.
Yeah,
/q
exactly.
/health
Yeah. And so let's add some limits too, right? So
Yeah.
Quarkus, Kubernetes, limit, resources, CPU, and then
put
what's
one. It doesn't.
yeah,
Here you
give it a
put-
full full CPU, sure.
Yeah.
And then
Yeah,
same with memory.
I'll put 4 gigabytes.
We'll do no,
Oh.
it's a Quarkus application.
Okay,
We
then
don't-
put 1.
That's already a
Well,
lot. I think
100,
that's
okay.
a lot. And then and then we would do the same for the limits and for the requests.
It's
So,
exactly the same thing. Yeah.
And so let's cheat a little bit and just grab them here. So I also
Because
have
it's a real
here-
long.
Yeah. So there we go. Control C. Up. Let's delete that. This mouse is working really strangely. Okay.
You can see here how you set the GDK Java option as well.
Yeah. And so let's see if our applications endpoints are there. So let's go to localhost 8080, where my dev mode is working, and then /q/health, right? And we can see
No,
we
because you need Docker.
it's still looking for the Kafka extension. Anyway, so yeah, let's pretend that worked.
But
Yeah, totally. It's okay. We'll see in our production application that it works.
no
So
worries.
yeah, let's pretend this all worked. This is the live demo effect is always a fun one. All right.
I think that they should burn also Windows Vista.
I know.
really.
We definitely
Yeah,
forgot
I
to
see,
pray
I
to the
see.
demo
Yeah.
gods. Oops. Oh, did
Because
you
at the end, now we've got a good initial values, but we need at the end to put more concrete values, right? Sometimes the initial values that I show you work, but sometimes you might need to figure out exactly if they are good numbers or not, or what could be good numbers. And a way to do this is by using observability. There are like 2 projects that I will mention here is OpenTelemetry and Micrometer. If you don't know exactly what is Micrometer, it's like Log4j. Yes, it's like for Log4, the Log4j, which is a wrapper around a log implementation. It's the same, but for monitoring systems like Prometheus and so on. So I think that Kevin, well,
Yeah.
the application is not working, but you
Well,
can
we
show.
can still show it. Yeah. So we can add in some more extensions, right? So Micrometer extension is one that exists in Quarkus, and then same with OpenTelemetry, so we can add that as well. And so by adding those extensions, what's going to happen is that we get metrics out of the box. So now if I go to /q/metrics, I get a whole bunch of information about, like what JVM is doing, what the garbage collection is doing, all those kind of
threads,
numbers, the threads, and blah, blah, blah.
Vertex, because under the hood, Quarkus is using Vertex, so you can also get all the information about Vertex.
Right. And so I'm just going to try it one more time. Let's see. Oh, it looks like port 8080 is blocked by something else. That's why it was. So maybe the other application might be running. So let's kill that one. Exit out of this. Come on. And then let's start it up one more time. And well, we'll see what's going to happen. In the meantime, I do have another container on my local machine that I'm going to start up, which has Jaeger running. So then I can hopefully trace my requests on my local machine, and if not, we'll just do it on production. Anyway, so let's go. Go back to the browser one more time to localhost 8080, and we can see, oh yeah, our Quarkus application
now
is actually running this time, and we can go
visit dev UI.
Yeah,
and
we
here
can
you
go visit the dev UI. So you can see in this case, because I removed the Kafka dependency, the Kafka card is gone. We don't have that dev services, that container is not running anymore, so handles all of that. But we can see now here we have micrometer metrics, and actually I should add one more extension, which is the micrometer Prometheus extension. And so if I add that, we're going to get some nice metrics formatted directly for Prometheus. So let's try that again. Let's let it reload real quick. Come on. Let's go.
And then we'll see in production, no worries.
Yeah, this is totally enough. Okay, so our Quark is dev mode. It's starting up again, and in a few seconds, come on. It's going to be up and running, and then we hit refresh. There we go. So our dev UI again, right here, and so now we can see that we have metrics here through with Prometheus. So I could go look at them here, or I can go and see the actual endpoints, which is at q/metrics, and then we can see all that information, which will be ingested by something like Prometheus, and then you can create cool Grafana graphs for that and everything. So I would say let's go to production, right?
Yeah.
So we have everything. We have our metrics and our tracing and everything. So I'm just going to create a few requests on my production workload in a minute, but let's take a look at it first.
Just go to the slides, right?
Yeah.
Maybe.
Yeah. Sure. That works. Okay.
Yeah.
Come on. Move. There we go.
Okay. So the last thing that to really quickly, if you ever need to have two services with high performance in the communication between them, so you need high throughput communication between two pods, I recommend you use pod affinity. Pod affinity will let you run pods in the same node. So obviously, if they are in the same node, means that the communication time is going to be faster. Okay, so if you have a pods that runs together, has a lot of interactions, and you want to have a high throughput, high performance, then use pod affinity. So I think that it's time to go into production, and of course we are not going to put to production this hello world application. We're going to put a real application, right? And this is the application that we're going to play all of us, because we will need your help, okay? Kevin, if you want, you can explain the game.
Yeah, absolutely. So let's imagine that now we did all this development, and we created our Kafka that actually works and everything. And so this application is using all that stuff that you kind of saw me develop, but not really. So anyway, so we're going to share a QR code in a little bit, and then you're going to see what's there on the left side on your phone, which is a little windmill. And so you're going to create green energy, right? Because we want to be green and sustainable and everything for our little race cars. And you can see, like we created just for this event a little Barbie car and a little Oppenheimer car. And it's going to be Team Barbie versus Team Oppenheimer. And so you're going to, by tapping on your phone, you're going to create power for these cars. So you'll be divided into two teams. So, if you're not a fan of Barbie and you end up in the Barbie team, it's okay. It's okay. So we'll see that our cars will be moving. So the architecture behind this game, so we have our mobile application. Well, it's not a mobile application, it's just a mobile website. Yeah. And so when you go to the application, it's going to assign a player, it's going to cache it in a caching database with InfiniSpan. And then every time you tap, you're going to just generate some energy events, basically, that's going to go to our Kafka.
And then Kafka updates,
exactly.
and then you will see the cars that are moving. We're going to see now in a moment, because now please use your phone, scan this QR code. I'm going to do it the same.
Yeah.
And let's play. I put the admin. Not yet.
Right. Yeah.
Just
first, everybody needs to scan.
Yeah. When everyone is, for example, in my case, I'm in Barbie. Who is in Barbie? Okay, we need to win. So tap fast the phone. Okay. It doesn't matter if you break the screen. Doesn't matter. We need to win. Okay. So
I'm just giving one more moment. Is everybody ready with scanning the QR code? I still see some people scanning. Okay, 3, 2, 1.
Okay.
If not, you'll get another chance to play afterwards, hopefully, if we have time. Okay, so here's our game. So I'm going to just refresh it real quick. And then we can see the players loading. So we got, let's see, 180, 190 people in Team Barbie versus 186 on Team Oppenheimer. It doesn't matter. It just takes the average of the players, right? So if it doesn't, is not exactly the same number, that's okay.
Okay.
Okay. So are you ready to play? So tap on your phone and go. And I'm going to just create a little picture or video or whatever. So everybody's tapping.
Come on, Barbies.
Come on. Wow, the cars are going super slow. It's going to need a lot of tapping. This is like super slow.
Come on.
Okay, tap with multiple fingers at the same time. Here we are talking about, go with your application to production. We know all the things that you need to do. It's going to work great. And then, this works great.
Oh, it's moving now. No.
Yeah. We're moving. Okay, so keep tapping with all fingers at the same time.
It's the first time that we play with so many people. Oh, no. Oh.
Wow. Come on, Team Barbie, you're running behind.
Okay. So here you can see the leader. And now we are updating, but it's Fraga. Who is Fraga?
Wow, nice.
Okay, so I'm 172, so not bad.
Wow.
Not
Okay.
bad.
Yeah, not bad. Okay, sure.
Okay, so we put here the game, and now, of course, our manager comes and say, hey, we want to update this application to a new feature, okay? And the application is in production, and we need to develop this new change and put it on the production. And usually when we want to put something into production, it's something like this, right? This is our application. All the developers saying, we are tested the application. We can go ahead, go to the production because the application is super great. It's going to work. So who is this guy? Probably it's the product manager or product owner saying, no, you're going to still not go to production. And this guy, probably is the architect. Right? They say, hey, here's surfing on my architecture and so on. And this one, the DBA. I'm sure it's the DBA, this guy, right? So putting on the production, it's hard. And the problem is that it happens once every time that we want to go to production. When in theory, it should be something like this. Something really smooth to production, okay? So for this reason, what we recommend is using GitOps. GitOps at the end is like an implementation of, we can say DevOps somehow, okay? That basically, you've got a Git repository with all your manifest, in this case, all your Kubernetes manifest there, so your infrastructure is also there, right? Or how you deploy the application, the dependencies of the application and so on are there. Everything is code, your application, but also the infrastructure. And finally, the great thing about it is that you are using the Git commands. Okay, so you can branch your infrastructure. You can have a branch for staging environment, a branch for production environment, a branch for performance environment, and so on. So you've got everything, all your infrastructure in Git. Okay? So now we suppose that we've done all this change, because the change now is that our manager is that he wants that we generate energy by shaking the phone, not taping the phone, shaking the phone. So let's deploy this new version.
All right. So this case, we're going to go straight to our repository.
Yeah,
so this is all in GitHub, by the way, right? So we got our little source code for the game, and we have a front end. So of course, we've already developed this feature. We're just going to turn it on. So we got our little web UI, and let's click on it. And then there's a source config. And so here we have our value to change to enable shaking. So let's do that. Come on.
Yep.
Wow. This mouse is being really weird. Okay. And so let's do that. So we could also change the team names and everything, but I think they're pretty awesome. So we're going to commit the changes, of course, commit directly to our main branch, right? YOLO.
Why not?
Yeah. All right, so I've committed my change, and actually we have a webhook that calls our pipeline. So it happens to be one that is running here in our cluster.
This is a Tecton pipeline.
Yeah, so this is using Tecton, FYI, if you're familiar with it.
Now it's running.
Yeah, we can see that it's running, and so it's going to do a git clone. Then it's going to do Maven build, and then create a container image, push that to a registry, and then we have another repository where the manifests are, and it's going to sync that, right? But
we've got a slide that I will explain you exactly what's happening now. Under the covers, you see here that basically we've done this. We've got a source Git repository. This is where all applications are stored. We did a change. Now we are running the CI part, so we are compiling, running tests, doing the container, and so on. And finally, we push this container to the image registry. Then, apart from that, we're going to send a pull request to the config Git repository. This config Git repository is where we store the manifest. In this case, it contains Kubernetes manifest there, deployment YAML files, and so on. Then, there is the Argo CD, which is a Kubernetes controller that is just there. It's like a daemon, right? Listening for any changes that happens on the config Git repository. And when it detects that there is a change, detects that, hey, someone has changed the tag of the deployment YAML file. Now the tag is not 100, it's 200. So it means that I need to do something. And this something basically is take action. Basically, it's applying this change. So it's going to apply this change to the cluster, and magically we will have our new version deployed to our Kubernetes cluster. So let's see if this already happened.
Is it really still only at the git clone?
Yeah, sometimes.
That's
well, I mean, we can check the logs.
Yeah. Yeah. It's like everything in the demos is not going right today. That's unfortunate. Let's pretend that that happened.
No, well.
Yeah, we'll give it a little more time. Anyway, we can show in the meantime. We can show what would happen. Yeah, I don't know why it's.
Why it's not cloning?
So should we try to rerun? Yeah, it's kind of weird that it's not even doing the git clone. That's
maybe GitHub is.
I haven't seen that one. Yeah. Anyway, so what would happen is that we would do a git clone, and then it would like Alex was saying, it'll push the image to the registry, and then here we have a GitOps engine. So in this case, Argo CD, and it would detect the change and then reload the new version of the application with the shaking feature, which sadly is not working. I don't know why. So, oops. Now we got mountains in the back.
Maybe, do you have the tag image of shaking created, maybe published, and we can change it directly?
We could. But I see that we only have 3 minutes.
Oh, okay.
So, yeah. I think we're out of luck. So maybe we can try it afterwards at the Red Hat booth, and for those who want to play. But yeah, so we're just gonna skip the demo.
Yeah.
This is very sad.
So,
or we can play again without the shaking. But yeah, we can see if we still have some time.
Yeah.
Anyway,
in any case, here are these books. You can download it for free in developers.redhat.com/ebooks. And also about the GitOps cookbook, we've got still some copies in the Red Hat booth. So if you come after the session, I will be there signing the book, and yeah, you can get it for free.
And I think that's about it. So well,
we can check if it works or not.
Yeah, we can try one more time and see if it's actually doing something. Come on.
See the pipeline? No, it's
Yeah,
not doing the
bizarre,
clone.
huh?
Yeah, but it's not doing a git clone.
Okay, who brought the bad mojo here, people? Anyway, so yeah, so sorry for that not working, but you got to play the app. Thank you. And yeah, you can find slides. So at this point, I think on Twitter, if Twitter also didn't bug out, you'll see the slides there. I posted them on my Twitter. If not, you can also find the link here. And yeah, definitely give us a follow. And then join us next time. We'll try to play this app again, and then hopefully it'll work. At least nobody got hurt, right? Because the shaking the phone, that sometimes doesn't work out so well. But yeah, thank you.
Thank you.